Welcome Honors Geometry students. If you have a packet printed out, you can turn to page 16. If you don't have it printed out yet and you'd like to print it out, we are on page 16, so hit pause, go print that out so you have it to write on. Great. So this warm-up, what do you notice about the Washington Monument and the reflection pool? All right. Maybe you noticed there's a reflection in it. Maybe you noticed the Washington Monument is above the water and it's also reflected below the water. Or the tree line, if you look above, reflects down. Kind of neat. The clouds in the sky are reflected down as well. All right. Your homework from session 1 was page 15. So we're going to look at a couple of them, but not all of them. So problem number 2, you're taking every single point and you're starting with x, y, and you're making it into x negative y. So if you started with 1, 1, 2, 3, 4, 1, 4, that ordered pair 1, 4 changed to 1 opposite of 4. So that point right there moved to positive 1, negative 1, 2, 3, 4. So this point reflected over and ended up there. So that one was actually one we hadn't discussed yet. So Moore had just been working on translation, so over 2 to the right and 1 up. Right? Over 2 to the right and 1 up. So this point, if this was A, this would be A prime. All right. Just so you can kind of check and make sure you're doing that homework correctly. All right. Also on page 15, it's asking you to describe what's happening. Well, here we took this function g and we translated 6 units to the right. 6 units right. Here we translated 1 unit down. And I know it's down because it's affecting the y. Here, 2 up and 2 right. All right. Great. So our first activity is on page 17. We're going to look at reflections. So your job is to reflect each of these images over that line. And I just labeled that line A just so that we can talk about it. So you're going to take this reflected over and figure out what the other side would look like if I reflected it over. That's not perfect. All right, you try it. Go ahead and hit pause. Try those 4, and then we'll check our answers. There's also a question down here. What is the relationship between the segment you drew and the line of reflection? Okay, so let's check that out. So here is kind of what you probably got. And notice these 2 red lines. We drew a line connecting the corresponding points, right? If this was A and this was A prime, we want to know what's true about that line. One thing that's true is it's perpendicular, and it's also equidistant, right? So if this arm is 2 feet above the ground here, it's going to be 2 feet below the ground there. It's equidistant. All right. Awesome. So here you're going to quickly reflect that ABCD parallelogram and label A prime, B prime, C prime, D prime on that new parallelogram below it. All right, hit pause and then hit play and the answers will appear. You can check your work. There we go. Just double check. Make sure you reflected A is farther away, so A should be farther away, right? You don't want to say A is close. Okay. All right, so we're going to do some explorations. This says we're going to discover the rules of reflection. So reflecting over the x-axis, right? So here is my x-axis, here's my y-axis. So we're going to reflect all of these points over the x-axis. It says plot the pre-image points, and you want to label them on your grid. You're going to connect them to form a triangle. Then you're going to fold the grid using the x-axis as the mirror line. Now, if you want to literally fold your paper, you can, if that will help you visualize. And then you're going to trace the image, like where did it end up? Another resource we're going to provide for you is this activity. So the first point is 2, 4. So you could go to this. This is reflecting over the x-axis, and you could put your point on 1, 2, 1, 2, 3, 4. So you could put your point at 2, 4, and then this is the reflection. So B is the reflection of A over the x-axis, and then you could look at that coordinate. So if you want to use this as a resource, we'll provide that for you. All right. So take a minute, and we want to see if you can figure out a rule. What always happened, right? So plot those 3 reflection points and then see if you can figure out the rule. Go ahead and hit pause. All right. If you haven't already made a prediction, you need to stop and do that, because if you take that away from yourself, then you're taking away half the learning. So please make a prediction. Thank you to those of you who already did, but there's still time. All right, here are the answers. So we'll see if we agree. All right, so check those out. See if you agree. So we started, this is the rule right here. We started with our original point x, y, and then what happened when we reflected it over this line, the x-axis, which also can be identified as the line y equals 0, right? Here's y equals 2, y equals 1, y equals 0 is the x-axis. The x value stayed the same. Nothing changed with the x value. The x value here is 2. The x value here is 5. Nothing changed with the x value. But the y value started up high at +4 and switched to -4. So the y value became its opposite. So this rule says x stayed the same and y became its opposite. All right, we're going to try that again 3 more times. So again, you're going to plot your 3 points, take a minute, but now you're going to reflect over the y-axis and see what happens. Okay, go ahead and hit pause, take a minute and try that. Figure out your rule. All right, if you haven't finished yet, make sure you hit pause. The answers are coming. All right, did you get that? So notice the y values stayed exactly the same. The y values stayed the same, but the x values became their opposites. So x flipped and became its opposite. All right, awesome. Okay, there's 2 more explorations. One is when we reflect over the line y equals x, the other's over the line y equals -x, right? So this is just saying if we said y equals mx plus b, the slope is 1 over 1 and b is 0. So, sorry, that's a y. Okay, so we started at 0 and we rise 1, run 1, rise 1, run 1, rise 1, run 1. All right, so it's just the parent function for our line goes through the origin and has a slope of 1. All right, so again, if you want to go and jump into this activity, we have listed these for you. So you can go check that. So the first point I think was at +1, 1, 2, 3, 4, 5, 6, which I can't get to right now, but this will show you where the reflection point is, and then you can analyze. So if this is 1, 5, this is 5, 1. Okay, but notice, whoa, notice what happens. Okay, so feel free to come explore this in your Desmos if you'd like to, but definitely identify those points and figure out what is the rule. So down below, this graph goes with this set of points, and this graph goes with this set of points, right? So these were the first 2 things that we addressed. If we reflected over the x-axis, what changed? So go back and look at your notes and write that rule in here. When we reflected over the y-axis, what changed? Write that rule in here. Then when you figure out what is this rule here, write that rule down here and figure out what would the points be. Just to clarify, we're not going first step, second step. No. We're saying, how did I get from the original to here? How did I get from the original to here? So take the original point and just reflect it over that line. Take the original point and just reflect it over that line. Okay? All right, so take a minute, explore those. All right. So make sure you've already made your predictions. On the next slide, in just a moment, I'm going to flip to the next slide, which has all the answers. This whole thing is going to be filled in. So if you haven't given yourself time to think about it, make sure to hit pause before I continue. Here we go. All right. So our rule here, if it reflected over the x-axis, x comma y changed to x. The x stayed the same. When we reflected over the x-axis, the x stayed the same, but the y became opposite. When we reflect over the y-axis, the y stayed the same and the x became opposite. When we reflect over the line y equals x, what happened? Yeah, x and y switched places. So the x became the y and the y became the x. And when we reflect over the line y equals negative x, not only do x and y switch places, but they become opposites. All right, these are rules that will always be true when we're dealing with reflections. All right, on page 20 and 21, there are some practice problems for you. Again, these are just one single thing happening. So this is saying, again, practice reflecting over the x, what happens, right? And then these are even more cool. You get to go backwards, right? So if I was here, how do I get back to the original? And then how do I fill in those? But you're just doing that one step. From the original, how do I get there? From the original, how do I get there? They aren't cumulative where we're not doing 4 different transformations all in one yet. All right, so make sure you practice that. And then here, they're asking, draw the figure if you reflect across the y-axis. So here's my y-axis. So I'm going to look at each point Q and reflect it over. I'm going to take I, I'm going to reflect it over, and I'm going to label these Q prime, I prime. Right? Here, if I reflect it over, it's on the exact same line. It doesn't change. I don't know what letter that was. I can't see. But E would be here, right? So whoosh, 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 whoosh. All right. And then it should be symmetric. It should look kind of like a butterfly. So, right, there's symmetry on either side. All right. So try those. And then one last. This one is saying here's the original, the pre-image, and the image. Write a rule to describe each transformation. Write a rule. Some of these are exciting. So some may be an extension, but you could just say reflect over this line, reflect over that line. So figure out where is the line of symmetry. All right, thank you all for watching.